Hello students, our next topic is about the affine and perspective transformations. So, affine and perspective transformations. So here, what is the basic difference in between them? Now first of all, let me take affine transformation. Here basically in affine transformation, if some lines are parallel in original object, then they are parallel in transform object too. While in perspective transformation, this condition should not be hold. So in this parallelism is maintained. Parallelism is maintained if lines are parallel, in original object, they are parallel in transformed object also. Hence, results are same as Euclidean geometry. Results are same as Euclidean geometry. General matrix for affine transformation, is, what was the general matrix? The general matrix is T equal to this A, B, C, D, E, F, G, I, J. It is as it is here. Here L, M, N are as it is. Here 0, 0, 0, 1. This is the general matrix for affine transformation. Now let us take perspective transformation. Already the difference I had taught. Perspective transformation. Now here the parallelism is not maintained, right? So in this parallelism is not maintained. If lines of any object are parallel, then in transformed object they may not be parallel. Object gets, due to that what happen? Objects gets distorted. And diagrams are difficult to draw in this case. diagrams are difficult to draw. So general matrix for perspective transformation is what? T equal to, that is 1 0 0 P 0 1 0 Q 0 0 1 R 0 0 0 1. This is the general matrix for perspective transformation. Now let us take what are the points, how the point P will transform with this. So P will transform to P star as P into T. So let's take P is what? X, Y, Z, 1. What is T is here with us. Right, this is a matrix T here. So now due to that, what we get here, this is X, Y, Z. Here Px plus Qy plus Rz plus 1. Here H equal to what? Px plus Qy plus Rz plus 1, and that is not equal to 0, right? So this can be written as x upon Px plus Qy plus Rz plus 1, y upon Px plus Qy plus Rz plus 1, z upon Px plus Qy plus Rz plus 1 and 1. With homogeneous coordinate 1, we can write this one as such. Here these are nothing but the coordinates of point P will transform to this one, and that is what? P star. Now the next thing, let's take plane geometric projections. Plane geometric projections. Now basically projection is a conversion of n-dimensional object to n-1 dimensional object. Okay, so like 3-dimensional point we will project on any plane, coordinate plane, then it will become 2-dimensional point, right? So projection is conversion of n-dimensional object to n-1 dimensional object. Okay, the plane geometric projections are projections in, or the projections of, 3-dimensional object taken on a plane, 3-dimensional object taken on a plane that is 2-dimensional system. In 3-dimensional system, one dimension is added. Dimension is added to 2-dimensional system. and through objects are three-dimensional, but display devices are two-dimensional. Display devices are what? Two-dimensional. This difficulty is overcome by introducing projections. There are two types. First, affine projection or parallel projection. Second, perspective projection. Now let us see what is parallel projection and perspective projection. So first, parallel projection. In parallel projection, Z coordinate is discarded and parallel lines from which projection are projected are extended until they intersect view plane. Center of projection is at infinity. So projectors are parallel to each other in this. Now let me draw a small diagram for this. Suppose here this is one plane of projection. This is a plane of projection. Okay. Suppose here the projectors, the point A dash, B dash is this. Here this is AB. These are what? Projectors. Okay. This A dash, B dash, it's parallel projection of AB. Now example for this one, here as the projectors are parallel, so this image will remain same. If original line is parallel, then the projection is also parallel. So parallel projection or affine projection, parallelism is maintained here. Example, first one, suppose X-ray photograph. X-ray photograph is one of the example. X-ray photograph of any organ. Second, Euclidean geometry figures. Euclidean geometry figures. Third, suppose shadow created by sun rays. Shadow created by sun rays. These are the examples for the parallel projection. Now the next thing, perspective projection. Second, perspective projection. This produces realistic views but fails to preserve proportions of length. Proportions of lengths. In this perspective projection, the center of projection is at a finite distance, from object, so projectors are not parallel. Now let's draw the figure for this. So it's what? Plane of projection. Okay, suppose here the AB. Okay, here this is a dash B dash. Here these projectors where intersect, and that will be a center of projection. These are what? The projectors. Here this length and this length are not same. So here the proportion of length is not preserved. So A dash B dash is a perspective projection. Of AB here. Okay. For example, first, human eyesight views. Second, photograph clicked using a camera, lens. Okay. Third, shadow created by a lamp post. Shadow created by a lamp post. These are the examples of perspective projection. Now basically the plane geometric projections are of two types, as we saw, right? They are of two types. Which are they? First one, parallel, and other one is what? Perspective. Parallel and perspective. But these are again of different types. So in parallel there are three different types. So first one, orthographic. In parallel projection there is first one type is what? Orthographic. Second type is axonometric. In that one again there are three different types. So first one is what? Isometric. Then diametric and trimetric. Again the third kind here in parallel, that is oblique projection. Now again in oblique projection there are two different kinds, that is cavalier projection and cabinet projection. Again in perspective projection there is a single type, that is single point perspective projection. Single point perspective projection. Single point perspective projection. These are, or this is a classification for what? Plane geometric projection. This one you should remember. This is a classification for that. Now remember this. We have to see further these things one by one. We will see these one by one. How does we can solve the examples on them. Now before that, let's take few definitions. Suppose the first definition is of center of projection. Center of projection. What does it? It is an arbitrary point from which lines are projected is called as center of projection. Center of projection. Second, projectors. So that's what it is. Rays drawn from center of projection are called projectors. Rays drawn from center of projection are called as projectors. Now one more, that is plane of projectors. It is the plane on which three-dimensional object is projected. Three-dimensional object is projected and two-dimensional object is obtained. Okay, so now this is about the classification of plane geometric projection, parallel projection, perspective projection, and then some definitions. Now here we will stop. In next video we will see the orthographic projection. Later on we will see axonometric projection, then oblique projection, and then single point perspective projection also with the examples. Okay, so thank you.